Hey guys, today we'll be watching a video on how to make quicksand and why it reacts the way it does by Charles Schaefer, David Choi, and Brandon Gonzalez.
We want to know how our mixture affects surface pressure and density on objects such as a toy, a spoon, and our hand.
Oh, hand!
2 hands.
Enjoy our video! We're keeping that.
No,
We're keeping that. Starting off with the ingredients. We use 16 ounces of cornstarch, which filled that jar to the top. Now you can use as much or as little cornstarch as you want. We also used a full bottle of water. Your water to cornstarch ratio will change if you want to make a bigger or smaller batch of quicksand. You'll also need a big container to mix your quicksand in, as well as something to mix it with, like a spoon. You'll want to start off by putting a little bit of cornstarch into your container. Now we don't want to add all the cornstarch yet, just in case you do mess up with the water to cornstarch ratio. Now the more water you add, the easier it will be to mix. Be careful not to use too much water or this will ruin the whole effect. Be sure to keep a little bit of extra cornstarch just in case you do add a little bit too much water, but we suggest that you keep it at a crumbling feel until your very end. Now I am going to speed this up a little bit as we go along. Now you want to keep mixing it in until you see it start to get smoother. Now as you add water and mix it more, you will notice that it will look more like a liquid as time goes by. Before starting our experiment, we questioned how the quicksand was going to be affected by different surface pressures and densities. We were guessing that objects with a wide area but little weight would not sink, whereas heavier objects with a thinner base would sink. We observed the toy sinking immediately. We suspect that this is the case since the toy was not coming towards the mixture at a fast enough speed. The jar stayed afloat for a second or so, but ended up sinking as well. We suspect that the wide area allowed it to stay afloat for a second, but the weight caused the object to sink. We concluded that a fast impact to the mixture would not sink the object, but in fact stay solidified at the surface, leaving no liquid onto the object. Now if you notice here, the mixture will act like a liquid if you let it stay in your hand. Whereas if you punch it or if you roll it in your hand, it'll act like a solid. Experiment number 1, punching. We found that there's minimal liquid onto our hand when we are punching this at a very fast rate. Experiment number 2, toy in jar. Now we added some food coloring here just to mix it up a little bit. We're pouring all of our liquid into our jar so that we can see if the Pikachu will drown or if it'll stay afloat. Pika, Pika! Now as you can tell, the Pikachu did drown very quickly, and we did test the liquid to see if it was too watery or not. The liquid seemed to be just at the right amount, but the Pikachu did sink. Now we'll be testing if the jar will stay afloat. As we said earlier, the jar did stay afloat for a couple of seconds because of the wide area, but did sink because of the heavy mass. Now we did start off trying to put the jar on the base bottom first, and we saw that it sunk almost immediately, but something that was kind of interesting was that it was actually really hard to take it out of the mixture. It did take some force. As you see here, we're kind of struggling here. Now this concludes our project. I hope you guys enjoyed it, and goodbye.